very quick demo. I'm just going to show you how the waveforms look, and we looked at these periodic waveforms yesterday. So here I have a simple sinusoidal waveform. So if you look at it, the magnitude is just 1, and the angular frequency is also 1, and the phase shift is 0. Okay, so if I plot this, I'm gonna get this wave right here, which has a magnitude of 1. So if you zoom into it, you see this peak, it peaks at the value of 1, right? So now let's go ahead and I'm going to copy this, and I'm going to add new equation, paste it, and I'm going to make this 5. So now you see the peak of this waveform is at 5. So this peaked at 1 and this peaked at 5. So just by changing this term right here, I'm able to vary the magnitude of the waveform. So that is the peak value. So whatever, if you have an equation for a waveform, sinusoidal equation, this first value denotes the peak. Alright. So let's go ahead and change the next variable right here. So I'm going to change this to 5 as well. And I'm going to next vary the angular frequency. So angular frequency is the term that is the coefficient of your time variable. So here my time is the x variable right here, and I want to change the angular frequency of it to 10. So remember, angular frequency is 2 pi f. So I'm going to change 2 pi f value, which was 1. Now I'm going to change it to 10. So now you see this periodic waveform becomes very fast. So the frequency just became higher. So I'm going to show you this. So this was our waveform with a magnitude of 5 and angular frequency of 1 right here. So that was our angular frequency. So now if you change the angular frequency to 10, this is what happens. Let's see what happens if we change it to 100. Now the waveform is very, very fast. Right. So that is what angular frequency means. So we saw by changing the first term, we change the magnitude. By changing this term, we change the angular frequency and basically how fast the waveform is. So now let me go ahead and make these two equal. So now these two waves are equal. So now I'm gonna change the phase shift. So there's a 0 degree phase shift. So the waveform follows this pattern right here. Now I'm gonna change this by 5. Okay. So let's see what happens. So you see this was our original waveform with 0 degree phase shift, and now this is with the 5 phase shift. So for a periodic signal, those are the 3 things that you want to know. It's your magnitude, this is your angular frequency, which this is the peak to peak, so peak to peak, 5 to negative 5, and this is the speed or the angular frequency, and this is the phase shift. So here you see this wave and this wave are phase shifted by 5. Okay, so now let me go and demonstrate a sine and a cosine wave, because a lot of times we think, okay, why are we just using a sine wave? Why not a cosine wave? So this is my sine wave, y 5 sine x, and I'm going to have a cosine wave as well. Alright. 5 cosine. So you see, like I mentioned in yesterday's video, a sine wave and cosine wave are just phase shifted 90 degrees. I guess so. That is it.